Hey guys, this is a demo video of Project 3. Here we want to know how to build a module into the kernel. And we first create a folder in this path. And we create two files inside it. After that, we use the command make clean and make to build our module. Make clean is to remove all the old object and executable files. And after clean, we use a make to compile code and create new object and executable files according to the make file we create in the last screenshot. After building our module, we first open another terminal and type in dnesg-wh to show the message of the kernel module. And in terminal 1, we type in sudo install hello module.ko and to load our module. And as you can see, the hello message from it has been showed in terminal 2. And if we want to know our module has been loaded or not, we can use this command ls-mod, and you can see that our module has been displayed in the first line. Furthermore, if we want to search the specific information like the hello module we create in last screenshot, we can use this command and it will show the specific information we want to know. Now we go back to terminal 1 and terminal 2. And in terminal 1, we type in this command sudo rmmod hello module. And by doing this, we will unload it on our module. And you can see that a goodbye message from this module has been showed on terminal 2. Here we can type in the search command again, and as you can see, we can no longer see the information of our module, and it means that our module has been loaded. Now we step into section 1.3, and here we want to load it and unload our module, and furthermore transmit parameters value into it. Therefore, here is similar as screenshot 1. We create a folder in this path and create these two files. And after that, we build our module by using make clean and make, and we type in sudo install parents module.ko and sudo rmmod parents module.ko to load it and unload our module. And you can see that here is a hello message when we type in smart, this one, and here is a goodbye message when we type in rmmod when we unload our module. Now we want to transmit these parameters modify values equals to 1 into the modules. And by doing this, you can see that here the hello message has been shown, but the string ID and secret value has been changed to -1 and -2 because this is a dummy message by setting this value. And when we unload our module, the values of these two variables are similar, is the same as the one when we are loading our module. Here, because we are transmitting the values of variables in a module into it, so we may want to know the data types of each variable, and you can use this command sudo modinfo parents module.ko, and it will show the data types and information of our module. Here, similar as previous screenshot, but this time we want to transmit more than one parameters into the module. So here we use this command and student ID equal to 612202007 and secret value equal to 8888. And you can see that a hello message has been shorted and the student ID has been changed to 6122007 and secret value has been changed to 8888. Here we have loaded our module, and since Linux manages module variables as files, so we can go into the folders in this path, which save these parameters, secret values, and we change it by using sudo nano to 7777. And after doing this, when we are unloading our modules, you can see that the secret value has been changed to 7777 when we are unloading our module, which implies that we can change it by directly going to the folder that itself. Here, if you type in wrong variable that doesn't show up in mod info, like this one, and it will be ignored. You can see here an unknown parameter dummy student ID will be ignored by the module. So you won't change anything, but the module will be still loaded. Here we step into section 1.4, and in this section we want to load it and unload our module automatically. So similar as previous screenshot, we first create a folder in this path, and inside this folder we create these three files. Here we want to briefly expand loader file, and the first part is loading the module. Here we're using file descriptor fd to open our module. This means that read only, and using fstate to read the content from fd to st, and set image size equal to st.st-size, which is the actual bits that the file has. And we set image equal to malloc image dash size, which is used for allocating the size of image size into the memory space of image. And after that, we using this command, and it is used for reading image size bits from FD and sending it to the memory that image point. And if all this went well, it will not have this one. But if init-module returns the value is not 0, it means that there have errors when we are loading our module, and we're using this to print out the error message. After that, we using these two lines to force the user need to press enter to continue this program. By doing this, we can separate the loading parts and unloading parts to separate it. And in unloading parts, it's basically similar as the loading one. Similarly, if delete dash module has returned the value is not 0, we also using these two lines to print out the error message. And if it all went well, we will close the file descriptor and free the image. And here we have loaded and unloaded our module. Now we open two terminals and using make interval1 to build our module and compile the loader unloader file before it. And we use it. And in another terminal, also type in the message -wh, and in terminal 1 we type in this command to execute the program we just write. And here you can see the module has been loaded, because here you can see the hello message from this module. And you can open another terminal and use these two commands, and you can see that the parameters folder has been created, and using this command you can see that our module has been loaded. And here we press enter, and you can see that the module has been unloaded. And here there are also a goodbye message from this module has been showed in terminal 2. And after we unloaded our module, we can type in these two commands again. And as you can see, we can no longer find the folder in this path, and we can no longer see the information of our module by using this command. Finally, we step into the section 1.5, and similar as section 1.4, we first create a folder in this path and create these three files inside it. And in this calculator.c file, we want to apply three different types of operation, which is addition, subtraction, and multiplication inside it. And I will use addition for this file to introduce the concept of it. And basically it's similar as the loading unloader file we just explained before. But in loading unloader file, we only need to transmit one parameter. But here we need to transmit two input numbers and one operations. Therefore, you can see here we use printf, and this is a string we will transmit. And by doing this, we can combine these three parameters into one line, and we will using this to transmit to the kernel module. After this, because we want to get our operation result from the kernel module, so here is similar as here, but we're using this to get our operation results from it. Basically, image tool is used for serving the result parameters, and we're using this to store the result in integer data types. Therefore, we have got the operation result from our module. And in calculator module.c file, we just apply this simple if-else condition to tell it which operation we want to use. Finally, after build our modules, we can run this program to test it. For example, if our operation is sum and the first input number is 2, the second is 3, the result will equal to 5. It's same as here. And if it's subtraction, first is 3, second is 2, here is the result. It's similar. And the third one is also similar as the message we see in terminal 2. And in this step, we have already done our project 3. Thank you for your watching.